Right, now, so new project. Console application, we'll call it library demo. And hit OK. And we now have an application called library demo. There it is. And inside here, you're perfectly OK. My class, if you like, and then we'll give it an int something and a string something else, and then in here I can then go my class equals m equals new my class, and it makes one, and we're all okay with that, are we not? Everyone happy with that? And this thing contains stuff, and I can work with it. And if I go in here, you'll see the same kind of thing. You've seen this in the bank accounts. You've done this every time you've made a class. And everybody's okay with that because it kind of makes sense. It contains methods which do stuff, and properties or members, data members, which hold information. And yeah. It's described as a piece of C# source, and we compile it and want to do things with it. And you're all okay with this, correct? Right. A storm of apathy. Right, fine. Okay. I can do things from the command line too. If I go, this is kind of fun. If I go, where do I make my projects? I can't remember. If I go save as, it'll tell me where it is. It's in, where is it? It's in, oh, library demo. Okay, fair enough. Let's go and look in there then. So if I open up Explorer and I go to desktop, is it library demo? Yeah, there we go. Library demo. No, don't rename it. Then I go into here and hit command prompt. I've now got a command prompt in that window. It's a bit hard to see, so I'll make it a bit larger. Properties, change to listen to console, and make it freaking enormous. That'll do. Okay, so now, and there are all my things. If I go CSC, do I get an error? Yes, I do. Jolly good. That wasn't helpful. Actually, I may be heading for a problem here because I've got the yeah, I've got a problem here. Oh, that's not helpful. I want the command prompt for Visual Studio, and I ain't got one on this because I'm running Community. Oh! Good thing it's not recording. Sad face. Right, okay. So I can't do my command prompt bit. Ah, life. Pretend we have a command prompt that works. Stretch, but there you go. I can say CSC myprogram.cs and I get a file with an extension .exe hanging off the end, correct? Yeah, lovely. That's fine, and I can run that file. Now, a little bit of background for you. As far as Visual Studio is concerned, actually what I could do, let's try and do some dual screen action on this, because I'm determined to wake you up and then go into the piece. Is the piece actually doing anything, or is it just me? If I do that, it goes dark. If I log in, where's that key on here? There you go. So I'm going to log in on there. It'll take about a week. On a good day, take about a week. And of course, this isn't being recorded, so people watching the video are going to be going, why is it still the same screen? Why can I see nothing? But I don't care about them because they should have turned up in the first place. Right, so, in fact, I might actually replace all the videos on YouTube with Ren and Stimpy cartoons when I get bored. So I should watch them pretty quick because they might change into something else. They might be Rickrolls. Wouldn't that be hilarious? Yes. Yeah, okay. So I'll leave that chugging and go back to, whoa, look all those icons. What a guy. My goodness, that's why it takes so long. Right, so if I go all programs, this will take you back to last semester. Visual Studio, where is it? let's use, what have we got? 2013, my goodness, is that old? Wow. Let's just try this then. Visual Studio 13 command prompt. I want command prompt. So it does exist. How can I find it then? I need an expert on Visual Studio 2013. Da-da-da-da. This is great. If you're still watching on the video, haha. Oh, blah. Here we go. Right. So, command prompt for Visual Studio. You'll do. Open it up. If I type CSC, I get a yeah. Okay. So if I go Notepad. Actually, do you laugh at Boaty McBoatface? Because that is just the funniest thing ever. I think it should. Well, maybe it's me. So Notepad. Notepad. We'll call it my. Yeah, I make a file called myprog.cs. I've no idea where it's being stored. I don't really care. And so if I now go here, what have I got to get? Is myprog in there? This might end badly when I save it. Okay, yeah. Right, fine. So what I'll do is I'll have to go back to drive H or G colon MD silly. Oh wow. I've already got us. Okay, this is interesting. What's in silly? Fred.txt. Right, okay. Well, there you go. Anyway, make a CS file like that. Yeah, I'll create it this time. Let me do it this time. And so now I can go into here. I can kill this guy off. Don't save. And now I can go. I was just thinking I could block copy from here to here. I can't do that. So. Public static void main. Not going well. Okay, so I'm going to make me a class that does not much at all. Hit tab. Tab that back in. So what should we make it do? Just print hello world, I guess. Now, you didn't know it was possible, did you? I've just done that thing that makes it go into the mode that does everything from the right-hand side. What the heck? Control Z? Okay, let's try that. No, there's a something down here that I've caught with my finger that makes it. That's better. Okay. Hey, but when someone leaves their terminal now, you know what to do, don't you? Yeah, okay. Oh. Okay, I'm going to make it write test. Will that work? Yeah. Save it. Compile it. Yeah. And it prints out test. So, if I do a dir, in amongst all the other detritus is this thing here called demo.exe, which is actually the executable. And I've gone from 105 characters of input to 3,584 bytes of executable, which is kind of impressive. That's an assembly. Okay, assemblies contain a whole bunch of stuff along with the code that actually does the work. Have I shown you ILDASM? Let's show you ILDASM. ILDASM is kind of funky. It's available for free. If I now go and I go open and we go on to drive. Oh, it's there, look. It's found already in silly. If I hit open, ILDASM is called the Intermediate Language Disassembler. Okay? And what this does is it takes a assembly and it has a look inside to see what's there. And it's found that, okay, we've got a manifest which has not got a lot in it, I don't think. And we have a class called myprog, and inside here it's got a thing called cutteror and a thing called main. What do you think that guy is? What's that guy? Ctor, CTOR. What is that? What could CTOR possibly be short for that all classes have? Constructor. That's the constructor which the compiler has provided for us for free. Okay, remember? A class has to have a constructor. If it's not got one, then what happens is that C# makes one for us. Fine. That's the method called constructor. This guy here is the method called main. And that's effectively the code that is running inside the main method as compiled intermediate. So in here, load the string test onto the stack and then call writeLine to write test out, then do a no-op for no good reason and then do a return. I can prove this works if I actually if I actually exit this guy and then I make a change here. So now I'm going to go in here and I'm going to go int, well, I'll go tab int I, and then I go I equals 99, and then I go I equals I plus 1. It's just going to really grip people, isn't it? And then I go in here test, and then I'll actually print out the value of I as well. So I'm basically bigging up this code a bit. So if I save that, it should print out 100, correct? Let's make it work. Bang, let's run it. It prints out 100. Now I'll do the ILDASM thing again. I've opened it again because if the file's open, the compiler can't write to it and it gets all sad. So if I hit open now, same old, go and have a look in main. It's got a lot bigger now. So here you go. Put 99 on the stack, store it in location 0, load it back from location 0, load 1 constant, add the two together, store it back in location 0. So this guy here we're assuming that I is held in location 0. Makes a lot of sense. So this guy puts 99 in there, this adds 1 to it, this puts a string on the stack, this guy does the addition to concatenate them down here, and then bang, we print them out. So this is the code that runs when your program goes, and it sits inside a file called an assembly. Does that make sense? It's quite interesting. It means that you can take somebody's .exe file and you can unpick it and find out exactly what's inside there and what the code does. There are better versions of this that make C# from the file. Now, there is some stupidness here. Wrong mouse. This guy stores the variable in 0. This guy brings it back. This guy loads the value 1, adds it and stores it. Now, there's probably more efficient ways of doing this. This is not the code that actually runs inside your computer. When I do this to run the program, when I type demo, then this intermediate code is converted into Pentium instructions that actually get to run. So this isn't the code that actually runs inside your machine, it's another version of it. And the idea is that if I want to make my .exe file run on a Windows phone running an ARM processor, or a tablet running Windows RT, or a Raspberry Pi, then exactly the same exe file gets pulled in, and on the Pi it gets converted to ARM code. On the PC it gets converted to Pentium code, which can be 64-bit or 32-bit. So this is called intermediate because it's designed to be a kind of halfway house. Does this make sense? It's a bit outside the scope of a C# course, but it's all good stuff. And what I want you to understand though is that when you do the compile thing, when you do this, then that produces an assembly file as the output. And so these things contain all the code assets, but they will also contain images and anything you want to put in there really, because remember that manifest thing? The manifest is basically a list of all the things this assembly contains, and it can be things like images and sounds. If you run a Windows app, might be sounds in that, there might be images in that. These are all part of the assembly. And so everything in .NET that runs is called an assembly file. And there are two flavors. There's executable ones, .exe, and there are library ones called .obj. Okay? Library assemblies don't have a main method. They just contain code. And the idea is that I write my library once, I put it in the object file, and then other programs can use that object file as a lump of executable code. Windows is built like this. Whenever you start talking about DLL, what does DLL stand for? Dynamically loaded library. It's a library that it goes off and fetches if it needs it. DLLs were invented because the early PCs didn't have much memory, and so you couldn't have the entire copy of Microsoft Paint in memory at any given time, wouldn't fit. So it's made up of DLLs, and the idea is that it fetches the library it's using now, runs through that. When it wants another one, it'll go and fetch that one might get kicked out, and we have this kind of ebb and flow of libraries in and out of memory as they go. As far as we're concerned, the interesting thing about libraries is we can make these things and tie them into our programs. Here is let's just make another, let's go back to my other screen. Sorry guys, on the recording. And if I go in here, I can go library.cs, and yeah, please, another file, that's good. So now here I can go class, I don't know, thing, since the things are in. And so in here I can have, I don't know, a method, public void, speak, and in here I can go system.console.writeLine with a little I, and then I'll just go yay. Okay, that's basically a class which contains a method called speak, which I now need to finish off because I've not done that quite right. Speak does that, and then in here I need to put the block that makes the body. So you're okay? You're okay with this? Thing has a method called speak in it, which I'm making a right mess of typing in. How did I get that wrong? Oh, never mind. It just prints out the word yay in a vain attempt to be cool. It's really hard to type on a keyboard when you can't see the keys. So there you go. That's called thing. What hasn't thing got? Has no main method. If I save it, I'll probably get tons of errors, but we'll see. So if I now go CSC, wow, shouty, CSC thing.cs, no, what do they call it? CSC library.cs. It says, I don't like you, you've got no main point. I can't run you, you aren't a program. Now, same with my account on the other screen that you can't see. This guy here has no main method, try and compile him, bam! Don't like that, no main entry point. That's because libraries don't have entry points. You're never going to run it as a program, it's just a library. What I have to do is change my compile command to say, make me a library please, not an executable. I do it by adding this. So if I now go back to the PC and go in here, I can get the same, I just have to go /target library. I'm saying write me a library please. I'm sorry about the choice of name, that was very unhelpful. But now it compiles fine. If I do a dir, then I now have a file called library.dll. That's the interesting thing. It's a separate file that contains the thing class and nothing else. Are you okay so far? Think about it. If you write a library if you write a lump of code that does something really useful that you want to apply in lots of different applications, you'd like to wrap it up in a chunk and just use that chunk in all those programs. And that's what compiling and making a library will do for you. Okay, so now library.dll, I can actually use that in my applications. Back to the slides. Okay, there's no main method. In fact, you put a main method in it fails. So now, what I can do now is I can use that as a reference in a program that I might decide to write. And I go csc/reference : reference file. You can put a list if you like, comma separated, and so that will now get brought in. So I'll show that in action. This is so exciting. So that's my class called thing, which contains a method called speak. Okay, so I can go back to here, close you down, open you up, and I can go, this might not work, but we'll try it. What could go wrong? That won't work. Thing t equals new thing. T dot speak. Okay, so I'm making a thing. I'm calling speak on it. I'm going to save that. If I just try and compile, my demo thing, it goes, I don't know what thing is. I have no idea. So that's not helpful. So what I do is I go back in here and say, okay, when you do your compile, take a look in library. Okay? So that will say, when you do your compile, can't find library. Have I spelled it wrong? Library. I do, don't I? Yeah. Still might not work. Ha, dear. You see, I can't see the keys. There you go. Okay, why is it complaining? Because I've made this thing private. How stupid of me. So I have to go in here and make this guy public. Like that. And then save him. And then rebuild the library. Cunning use of up arrow now. Rebuild the library. And then get it right. Now, when I run demo, it should print out yay. Now, I hope you get an idea for what I'm doing now. I have a single assembly which I can now use in as many different programs as I like. Does that make sense? So this is a way in which I can share bits of code amongst all my other programs. Only one main method, which is fine. When I ship the program, I have to ship accountClass.dll as well as the .exe file because my program is now spread over two separate source files. In fact, if you look at the code, what happens is that when the program runs, when this guy runs, first thing it does, it loads up the class myprog. It then goes into the main method and it gets down to here and it goes, oh my goodness, I need to make a thing. I'll go off and find thing.dll, bring that into memory. I'll find that the actual DLL file that lives in, bring it into memory and use it from there. So these guys are brought in when they're needed. Interesting thing, it won't be loaded into memory if it's never actually called, because this thing all happens on the fly. If we go back to, wrong mouse, if I go back into here and I do my ILDASM thing again, if I can find it, and we reopen, I could open demo or library. Let's open demo, have a little look. Yeah, that's the code for the, and then if I now go here, I can open the other guy and have a look in there. So thing doesn't have a main method, just has a method called speak, and speak puts the word yay on the stack and then calls writeLine to print it out. That's how these guys work. And I was hoping to find somewhere in here is actually the manifest that says what it's actually using. I can't, there you go. Can't quite find that. Secondary extended, it should say somewhere there's a requirement for this guy to actually make use of that library, but I'm a bit, haven't done these things for a while. But anyway, can you see where I'm going with this? Someone here should mention the fact that it's external.
Assembly external library.
Yeah, it's there, look. That's the bit that says, I need this library as well, please, otherwise I can't work. This all makes sense? I'm glad there's a few people awake. It's a pity one of them's not me. So, I can do all this from the command line. Actually, it's much easier in Visual Studio because it'll manage it for us. It does all the heavy lifting for us by itself. So if I go back into here now, and I go back into my sample app here, if I right-click on Library Demo, and right-click on the solution, and I go Add, and I go Existing or New Project, I can make myself a new DLL, Windows Library, where are we? Class Library, bang. Okay, now what happens now is effectively I've added a new source file. In this case it's called class1.cs. I can compile this guy and, well, let's call it class1, why not? So now if I go in here, I go public void speak, say, and then we'll just go console.writeline. So, oh gosh, not going well today. Get this line, okay. Do that, okay, so now I now have a class library in the same project as this guy. So you might think I could go into my program and I could make myself an instance of, what did I call it, class 1. I think it was called class 1, wasn't it? I can go into class 1, Fred equals new class 1. Why does that not look like it'll work? Well, it's because, I'll just finish this off. If I go back in here, this won't work because at the moment these two guys aren't connected. I have to go into references and I have to say add a reference, and the reference I'm going to refer to class library, please. Okay. So now that means that this class is now using the library, and I also have to go into here and actually use his namespace, which more in a second. So if I now go into there and say this, look in the class library for things, and now when I try and make Fred, it'll work. And if I go Fred.speak, even the IntelliSense lines up now. So if I run the program now, it'll print out hello from Fred, I guess. Hello from class 1. It just shot up and then vanished. I'll put a breakpoint in so we can see it a bit better. Bang. Hello from the class. So what I'm saying is that if you want to do the same kind of thing in your programs, then you can actually make additional projects. And the thing which is interesting, just one final thing to square that off, if I go into my solution again and I right click and I say add, I can add an existing project. So I can go off and link through to an existing library somewhere, which I can then pull into this particular program. So the cunning thing about this is that I can actually use the same library in lots of different projects, which is kind of where we're going with this. Lots of libraries are part of the operating system and the Windows environment. Things like forms, all the math stuff, console.whatever, these are all DLLs that are brought in when you need them. Windows maintains a global cache of really popular libraries which are effectively always in memory. You don't have to worry about that. The system sorts it out. But what I want you to understand is that the way we've just made those two classes talk to each other is the same way that huge chunks of Windows actually work. And this is what I was just saying, only in slow-mo. You can make your own user libraries in Visual Studio, and you can then do what you like. But just to bottom out the next bit, I want to talk just for a few minutes about namespaces. So before I do that, everyone okay with what a library is, kind of? Can you see a context in which it will be useful, where I can split my program across several source files and I can reuse some of those components in other applications? So I can write general purpose bits of code that I can then plug into other apps. Okay, so that's fine. I've kind of mentioned namespaces. I want to really square it off now. I think that one of the most important things about being a good programmer is picking sensible names for variables. Calling something X or Boaty McBoatface would be a good variable, a bit long to type, but you could do it. The compiler has no strong opinion on this, but I like things like window height in meters. I love that because it tells me exactly what the variable has in it. And it even gives me the units. Pay and funds is a good name too. It's a verb noun kind of thing for a method somewhere. So I like these names. We pick good names. Snag is that good names are popular. You might have a class called menu. Somebody else on the same system as you might also make a class called menu. Can happen. Needs to be a way of making sure that names don't clash. And C# provides a thing called a namespace, which is basically a context in which names have meaning. And we can create our own namespaces and populate them any way we like. And names we create in our own namespace are unique and special to us. It's all to do with context. If you say, that team is really on fire, if it's a football team, that's probably quite good. If they're all firefighters, it's less good. Okay? So a particular context of a remark has a big difference in terms of what it means. And so with namespaces, what we're talking about is actually a context in which names have a particular meaning. And this is how we do it. You've seen that C# does it for us when Visual Studio makes a project. We just give it the word namespace followed by the namespace followed by a bunch of classes. So inside my bank classes namespace, I have two classes. One called account and one called address. Within the namespace, they can refer to each other directly. So account can talk about account addresses and address can talk about accounts. Outside that, we have to do a using to get that namespace in. So yeah, accounts and whatnot. If you want to work outside the namespace, you can do this. You can make a fully qualified name. And that's basically namespace.account, well, namespace.classname, wherever you want to use it. Does that kind of make sense? So this is basically a context. The World Wide Web does something very similar with URLs. In that you can everyone has a page called index.htm, but they all have a different web address prefix in front of that. And you can make subdirectories on your website that all have index.htm in them, and they'll all just work. So it's exactly the same principle. If you don't want to have to keep on typing in fully qualified names, put the word using in front. Beginning of your program saying bring in, I can give you an example of that very easily, because I can go in here, I can take out my using of class, well I'll just do this because I'm clever, I'll just copy that and then delete this thing. Okay, so now class1.fred does not work because I'm not bringing the namespace in from my library. But if I make these guys fully qualified, which I can do by using the magic of block copy, then now everybody's happy because this is now a fully qualified name that has the namespace followed by the class name. Okay? So if you want to use fully qualified names, that's fine. If you want to abbreviate them so that you just have to give the name and the system looks in the namespace all by itself, use using. It's up to you how you do that. We've been using system like forever. Although when I wrote my test program on the other PC, I did system.console.writeline. I already spotted that, so that I was sure it would work, just in case it didn't have the namespace loaded. So, if you add too many, this is one of the things that concentrates my mind a bit. If you look at what Visual Studio does for me, it brings in a whole bunch of namespaces for me automatically. It's rather pleasing in that it does this, it grays them out, which means anywhere in this source file, nothing is using anything from this namespace. And you can actually delete them. You can use one of the wizards to do that. I get into problems if I write Windows applications which use the media framework and the forms framework. Both of those have the idea of a thing called color. And it's annoying because you type the word color and it gets confused. And so you have to start putting in fully qualified names. I try not to use too many usings. In fact, it's almost an argument for using fully qualified names all over the place, because at least then people know where to go and find that. Although it's not quite so bad with IntelliSense, because it can find things for you all by its little self. So yeah, as many namespaces as you like, which makes sense. If you get a clash, the compiler will refuse to compile and say, I demand a fully qualified name, please. Otherwise, I don't know which class to use. And if you want to, you can put namespaces inside namespaces. That's not a bad idea if you're building a hierarchy of objects, and they can all exist in their own namespaces. And that's something which the Windows environment itself uses quite a lot. System.io is a namespace inside the system space, and there's quite a few of these all over the place as well. If you build an app, like I was saying before, you have to make sure that the library files are included with the executable. Some programming environments put everything in one big file, so your .exe holds everything. That's not how it is with C# and .NET. The DLL files have to be there as well. And there's one other layer of nasty, which is that all the DLLs and all the EXEs are versioned. So C#. So if you use an old version of a library with a newer version of the program, you can get it to fail at runtime because it doesn't like the fact that two guys aren't in sync. So yeah, that's fine. You don't have to put all the classes in a single source file. You can spread your namespace over as many files that you like. Studio will actually bring all these together when it builds the application. It does that for you auto-magically. And yeah, so as far as we're concerned, the reason we've had this little chat is that it's useful to be able to break your program into chunks. And this is like in a physical level where you have different assembly files, and it's at a logical level where you have different namespaces where you've located things by virtue of their name. Assemblies can contain code from lots of different namespaces. That isn't a problem, but effectively now you've got two different ways you can partition your app. You can spread it over several DLLs, and you can spread it into several different namespaces. That's kind of how it works. I'm sorry about the fun with the command prompt, but we did manage to get there on the end. But before I stop, anyone got any questions on this?